Hi, I'm David Arpin, and I'm here to talk to you about Amazon SageMaker and how you can use it to build, train, and deploy machine learning models in AWS. Today, we'll walk through an overview of Amazon SageMaker at a high level. Then we'll spend most of our time walking through a demonstration where we show off how to use an Amazon SageMaker custom algorithm called Blazing Text to do cold start recommendations. And then we'll end with a little bit of Q&A. So just to start off, let's talk about how Amazon SageMaker fits into the broader machine learning and AI stack at AWS. At the top of our stack, we have our application services. These are tools like Recognition, Poly, Transcribe, Lex, Translate, and Comprehend. They're focused on a specific domain area, and they allow you to very quickly and easily use a pre-trained machine learning model to generate predictions with a simple API call and you passing your data. And very quickly and easily integrate machine learning predictions into your applications or services. The next layer down is the platform services. This is where Amazon SageMaker falls. The goal of the platforms is to allow you to develop your own customized machine learning solutions and give you the tools that you need to do that effectively and expediently. And both of those layers sit on top of the frameworks and hardware. This area is focused on making AWS the best place to run a variety of deep learning frameworks, whether that's TensorFlow, Apache MXNet, PyTorch, or any of the others, as well as focusing on giving you a variety of compute options for whether that be GPU instances like P3s to train your deep learning models, or whether that be CPUs to do inference or training, or IoT or mobile device. So when we think about Amazon SageMaker, we like to think of it as three independent components that are tightly coupled. So you can use these three components together, which is how we think the service works best, or you can use each one independently and pick and choose a combination of one, two, or all three of the components to use together. And those components are build, train, and deploy. And then on top of those three components, we've layered additional functionality like customized algorithms that we've developed in-house, pre-built framework containers that you can use to run your deep learning framework code, as well as the capability to bring your own algorithm with a Docker container, and then SageMaker's automatic model tuning, which can work with the algorithms frameworks or bring your own container to optimize your machine learning models by finding the best set of hyperparameter values. So going into each component in more detail, when we think about build, we think about the different ways you can interact with the service. So SageMaker has notebook instances, which is the quickest and easiest way to get set up with an instance that's running a Jupyter Notebook server that you can use to interactively explore and experiment with data, run snippets of code, document your progress, and visualize your results. But we also have other ways to interact with the service as well. We've developed a SageMaker Spark SDK, which allows you to easily integrate your SageMaker training and SageMaker hosting into your Spark workflows and pipelines. We also have a console that allows you to orchestrate or manage your resources, as well as use a point-and-click experience to create training jobs or spin up endpoints. And then finally, you can always access SageMaker from your own device, whether that's an EC2 instance or a laptop. The next component of Amazon SageMaker is our training environment. So Amazon SageMaker provides a very easy way for zero setup, distributed managed training. So when you create a training job in SageMaker, we actually spin up separate hardware for you, provisioning new instances, loading a container which has algorithm code on it, bringing your data in from S3, training the algorithm, outputting the model artifacts to S3, and then tearing down the cluster without you having to think about managing that or orchestrating that yourself. We provide additional functionality as well in SageMaker training, support for things like streaming data sets, where we stream data directly from S3 into the instance so that you can begin training on it instantly, as well as distributed compute, so setting up a cluster of instances that can be used to orchestrate distributed or parallel training. These are built to use existing technologies that you may already be using or used to. Things like Docker containers. Every algorithm in SageMaker, whether it's a customized pre-built algorithm or whether it's one you bring yourself, is a Docker container that's stored in an ECR repository. And then finally, this goes to SageMaker's modularity. When you've trained your model in SageMaker, you can deploy that trained model either locally to a SageMaker endpoint or to a Greengrass or DeepLens device. Now, when we think about deploying our model into production with SageMaker, we can do that a variety of ways. We can use real-time hosted endpoints. We've set this up to be very easy one-step deployment so that you can get a production-grade, auto-scalable, high-throughput, highly reliable endpoint that you can do a variety of different things with. This is going to be your own REST API that you ping with an HTTP post request to get a prediction back from your machine learning model in real time. We also support A/B testing in these endpoints, so you can deploy multiple models behind the same endpoint. And the endpoints support blue-green deployments, so even as you update or reconfigure your model or endpoint, you don't experience downtime. And then again, it's all modular, so even if you've trained your machine learning model outside of SageMaker, you can still bring that model in and host it on Amazon SageMaker's managed hardware hosting infrastructure. You can also do batch prediction with Amazon SageMaker. So if you have a large number of predictions that you need to make all at once and you don't need a persistent endpoint, you can use the zero setup environment to spin up specific instances that are going to stream data in from S3 and stream predictions back out to S3. They'll distribute that workload across a number of CPU and GPU instances and then tear down all that hardware afterwards. So you only pay for the time it takes to generate those predictions. And again, with this functionality, this batch prediction functionality, you can bring your own model that you've trained outside of SageMaker and still take advantage of it. The next layer of functionality we have is the customized algorithms that we've developed for SageMaker. These algorithms are often an improvement in both science, in that their methodology is different from a standard open source implementation of the algorithm, and engineering, in that they've been designed to take advantage of things like distributed training as well as GPU acceleration. And we have an eclectic mix of algorithms. Some common algorithms like linear regression and classification that people are aware of, some unsupervised algorithms that are very common like k-means and principal component analysis for dimensionality reduction. As well as some deep learning algorithms that have become popular in recent years, things like image classification with ResNet or object detection with single-shot multi-box detector SSD, and sequence-to-sequence for neural machine translation, and word-to-vec for word embeddings, which are both in the natural language processing space. And then we also have some algorithms that are purpose-built, so designed for a specific purpose. We have a deep AR forecasting algorithm, which is one that we actually built in-house in Amazon to help generate predictions for a large number of related time series and do a more accurate job than you would probably get if you tried to build an individual model for each time series that you had to predict for. When we think about the deep learning framework containers, our goal was to design an easy way of working in which you could sample your data, train locally in a small instance, debug your TensorFlow, PyTorch chainer, or MXNet scripts, refine and your network architecture, get something you're comfortable with, and then use that same code but deploy it to SageMaker's managed training instances in order to train on the full data set in potentially a cluster of many GPU instances. So really allowing you to easily scale from one instance to multiple instances. And then once you've trained that model, easily deploy those into production so that you have high-performance serving environment that you can generate your deep learning predictions from. For the bring your own approach of a Docker container, we've developed this so that you can still take advantage of things like SageMaker training and hosting even if we don't support the framework that you've chosen. So if you have an algorithm in R or Java or scikit-learn that you'd like to bring and train in SageMaker's managed training or hosting, you can do that by bundling that algorithm code up into a Docker container and publishing that container to ECR. Finally, when we think about training our machine learning models, hyperparameter tuning is a very important aspect as it can really change the quality of your model fit. So SageMaker has a tool called automatic model tuning that allows you to orchestrate many training jobs, and it kicks off lots of different training jobs with varying hyperparameters as it simultaneously searches this hyperparameter space for improved accuracy. It actually builds a meta model on top of your machine learning model that tries to predict which hyperparameter values are likely to lead to the best fit, and then uses Bayesian optimization to do a combination of exploring and exploiting that hyperparameter space to really result in the best model in an efficient number of training job runs. Now we'll go through a demonstration of how to use Amazon SageMaker. So, starting off in the AWS console, to access Amazon SageMaker, you open up all services, scroll down to machine learning, and click on Amazon SageMaker. As you can see, we're greeted with a dashboard that gives us information about the different components of Amazon SageMaker, as well as our recent activity of notebooks that we've created, training jobs that we've run, or models, endpoints, and batch transform jobs that we've used. Going into each component in a little bit more detail, the notebook instances are here. These are instances that we can that are running a Jupyter notebook server on them, and we can easily create new notebook instances or open existing ones and manage them from the console here. We also have lifecycle configurations, which allow you to set up scripts that ensure that every time you spin up a notebook instance, it contains the same libraries and has the same configuration sets. We have a record of our past training jobs that we've run, as well as any past hyperparameter tuning jobs that we've run. On the hosting side, we have trained models that we want to be able to host for inference. We have endpoint configurations, which describe the hardware configuration and which models we're going to put behind an endpoint. And then our endpoint section, which shows certain endpoints that are actually instances up and running and in service within our account. And then we can also look at our batch transform jobs, which are past runs of any batch prediction that we've done. So returning to the notebook instance, to get started, we can create a new notebook instance. We can define our notebook instance name, and we can select from a number of different instance types, whether they be small CPU instances that we might use for orchestrating larger operations on other AWS hardware, whether that be a Spark cluster or whether that be using it to create training jobs in SageMaker's distributed managed environment. Or we can pick large GPU instances if we intend to do a lot of our processing on the notebook instance itself. We can also select and create an IAM role, and this makes sure that we have the proper permissions to access data or execute the functionality that we need from our SageMaker notebook instance. If we create a new role, we're greeted with a screen that allows us to select which data we have access to. For this particular use case, we'll select any S3 bucket and then create that role. We can add our notebook instances to any existing VPCs that we have, associate any lifecycle configurations, and as well as encrypt the data through KMS. So we'll click on Create Notebook Instance. While that's spinning up, let's open up a notebook instance that we already have running in our account. So when we click on Open, we're greeted with the Jupyter dashboard. And you can see we have a listing of files that are available on our notebook instance. We can look and see what functionality we have running, open terminals and existing notebooks that are running. We can click on SageMaker examples, which is a set of predefined notebooks that we load to the instance that really show you how to get engaged and get started using Amazon SageMaker. So we have introductory examples that cover how to use the different SageMaker algorithms. We have ones that talk about how to apply machine learning to real-world use cases. Those that cover our pre-built deep learning framework containers. Those that cover how to integrate SageMaker with Spark. Any advanced functionality, so things like bringing your own container algorithm, as well as how to use hyperparameter tuning, and any scientific details about our algorithms. And then finally, the Conda tab describes the environments that we've created for you on your SageMaker notebook instance, as well as allowing you to track which packages. We've tried to populate the SageMaker notebook instances with a lot of very common data science packages, but you can always install and add more as needed. So for our example, we're going to open up this blazing text Amazon reviews folder that I've created. We'll open up one of the notebook instances, or one of the notebooks. And in this example notebook, you can see we have a mix of documentation through Markdown, as well as Python code that can be run by clicking on the Run button here. And so this is going to sequentially run our cells in order to run through our example code in this notebook. And so we can walk through it as we go, but for our case, we'll transition over to a pre-run notebook so that we can see all of it at once. So the example notebook that we'll cover today is using SageMaker blazing text to find similar items for cold start recommendations. So recommender systems are really a catalyst for ML machine learning's popularity, whether that's Amazon's people who bought this also bought that, or the $1 million Netflix prize that spurred a lot of research in machine learning. They're a very popular use case that are broadly relevant to a large number of customers. A user item matrix factorization is one of the core methodologies that's typically used. So when you do user item matrix factorization, you start with a group of users and a number of items and some sort of rating or purchase quantity associated with that user and that item. Now we also have missing values since most users haven't rated most items. In order to predict these missing cells, we factorize this matrix into two smaller submatrices. And we can then multiply these two matrices out to get predictions for our missing cells. This will allow us to then generate which items we think a user would review highly that they haven't already reviewed or haven't already purchased, and suggest that particular item to them. However, matrix factorization has difficulties when new items are added. This is commonly referred to as the cold start problem, and you don't have a column for an item when it hasn't been added yet, and so you don't have any historical reviews to be able to find similar items to that. And so matrix factorization can struggle in those use cases. We're going to use an algorithm called word2vec, which would actually typically be used in the natural language processing space in order to generate word embeddings. And with these word embeddings, each word in your text gets a single vector associated with it of numbers. And that vector may be 10 elements long or 100 numbers long. But words that mean something similar tend to have numbers that are very similar. They tend to be very close in that embedded dimensional space. So how we'll use word2vec is concatenate our product titles. In this case, we're going to use Amazon digital video reviews. And we'll use our customer review history as our sentences. So videos that are watched close by one another will be more closely related than those that aren't watched together at all by a customer or are watched very far apart. And SageMaker Blazing Text is really nice because it's an extremely fast implementation of Word2Vec, and it also has the capability of working with subwords, which means we can actually take the word, or in this case the video title, and break it down into smaller strings of characters and find similarities, which will help us with that cold start problem. So SageMaker notebooks tend to have a very common setup. They define an S3 bucket, which is where we'll store our data. They'll define an IAM role that sets up our SageMaker permissions and permissions to access data. In this case, we have a SageMaker Python SDK, which is a library we've written to make it easy to orchestrate some of these actions and make it easy to call SageMaker's APIs in a data science friendly way. And in this case, we'll just use the default bucket, S3 bucket, and we'll get the execution role that's already been associated when we created our notebook instance. We'll then import the necessary libraries for this example notebook. So this includes pandas and NumPy, which are common in the Python data science space, as well as our SageMaker Python SDK, and things like Boto and JSON for interacting with the rest of the SageMaker components. We'll also load a data set. So our data set that we're going to be using today is this Amazon reviews from, it's an AWS public data set available in S3. It's got 1 to 5 star ratings from 2 million plus Amazon customers and over 160,000 digital videos. So we're going to copy that right from its location in S3, and we'll read it into a pandas data frame, which is a great library for manipulating tabular data in Python. So if we look at that, we can see that we have a variety of fields. We have which country these reviews are from, an ID identifying a specific customer, an ID identifying the specific review, a product ID which maps to a specific digital video, product title, so we can see that this product ID is Enlightened Season 1, and then some information about what the star rating was, helpful votes, as well as the text of the review itself and when the review occurred. We're going to limit down to just the most important fields for our specific use case. So we're going to keep the customer ID and the product ID so we know which products they reviewed. We'll keep review dates so we know when they reviewed them, and that title so that we can use that for our word embeddings. We know just from history that most users don't rate most movies. So we have a very long tail, and we can see here that indeed 90% of customers rate 4 or fewer digital videos, and that 75% of videos are rated 9 times or less. So we're going to filter out some of those as they wouldn't provide a lot of information to our machine learning model. So that's the step that we run here to reduce our data frame down to just the most popular items and heavier rated viewers. We're then going to concatenate those product titles so that each product title is seen as a single word when we generate embeddings. And we'll write that customer purchase history data out to a text file, which is the input that SageMaker Blazing Text is expecting. You can see I've done a quick head command. When I use that exclamation point, instead of running Python code like we have been so far, we'll run actually a shell command. And we can see this customer purchases data that we just output is just the movie titles separated by a space in order that the customer reviewed them. We'll write that data set out to that text file out to S3 so that SageMaker training can pick it up and begin using it. Now when we want to train an algorithm in SageMaker, we create a SageMaker estimator and we specify a few things. The algorithm container location. So as I mentioned, this is whether it's an algorithm that's a customized, pre-built algorithm that we've created on the SageMaker team, or whether it's your own algorithm that you've brought, it's all an ECR image path that we point to. We will define the IAM role, so we have permissions for data and SageMaker functionality. We'll define the hardware configuration for our training cluster. Notice that even though we spun up a relatively small CPU instance to orchestrate this, we're going to train on a GPU instance to really accelerate our training. We'll also define the output path for S3, and then we'll go down to the next step, which is defining our algorithm hyperparameters. Some of the important things that we define here are things like word count, where we remove titles that occur less than 5 times, our vector dimension, so that's how many numbers each video in this case is going to be represented by in that embedding space that we generate. Subwords, so this is going to be used to capture similarity in individual words of the video titles. And we specify min car and max car, which is going to give us our character limits for those subwords. Now we'll start the SageMaker training job by running .fit. And you can see we actually go and provision instances, we load the algorithm container, we load data to S3, we train our model, output the model artifacts to S3, and tear down the cluster without you having to think about anything. SageMaker does that on your behalf. So when you run .fit, rather than in a Python library like scikit-learn where you would pass in a in-memory array, we're going to pass in an S3 path because that's where SageMaker training is going to pick up our data. So we've passed in our S3 location, and it will begin provisioning instances and take a little time to do that. But then once it starts training, logs will cascade in right to our notebook. We can also find these logs for posterity in CloudWatch where they're available. And you can see at the end, we've only run our algorithm, even though it's a real-world large data set and a computationally intensive algorithm. Because Blazing Text is such a fast implementation, we've run it in just under 3 minutes of billable time. So we've spent a lot more time talking about that and using our CPU instance to orchestrate that. But we really only pay for the GPU time for that 180 seconds. So that's an important component of separating the compute and training with SageMaker. Now, let's go look at the model. So we take our model artifact and we output it to S3. SageMaker does that. And we want to bring that model artifact in and take a look at it. So we'll run an AWS CP command, and we will unzip the model.tar.gz that the SageMaker algorithm creates. We'll read that into a pandas data frame, and we'll start to look at it. And you can see we have each of our videos, and then 100 numbers that represent those videos. And what we've done here is we've sorted on the first dimension in our embedding space. And you can see, for the most part, Spy Kids 2, Baby's Day Out, this seems to be a dimension that represents maybe kid movies on one end. And then as we scroll down to the opposite end of that spectrum, where we have large positive values of that first dimension, we have things like Law and Order Special Victims Unit, decidedly not kids material. So that first dimension in our embedding space may represent something about how kid-friendly the video is. Now we'll go to sorting by our second dimension. And we can see Murdoch Murder Mysteries is a common video there, common occurrence at that end of the spectrum. And then at the bottom, we have a lot of horror films. So Devilfish, An American Terror, The House of the Devil. So, this may tell us something about classic mystery versus maybe gory horror in this dimension. And we have to evaluate each of these embeddings subjectively because they can change over time. But there's 100 of them. So rather than continue to go through these one by one, we'll actually reduce this further by using a technique called tsni and embed just the top 100 titles just to validate and make sure we're comfortable with everything in our model. So we've done that, and we've created a plot here. we'll look at that plot, and we can see that indeed products that we would expect to be similar to one another show up nearby one another. So all the seasons of Downton Abbey are very close in that reduced dimensional embedding space. And not only that, but they're also close to another masterpiece production called Mr. Selfridge. On the other end of the spectrum, we have things like Hunger Games, Marvel Avengers, Skyfall, so big budget action films. And over here, we have things like Transformers: Age of Extinction and RoboCop. So we have this real unique ability in this embedding space to say that these things that are close by one another tend to be kind of reviewed in a similar time frame or watched in a similar time frame by our customers. Now that we're confident that we like our model, we can go to the hosting side. So we can deploy our model to a real-time production endpoint. We can do that very simply by just taking the estimator that we fit and running .deploy and defining which hardware. Notice again, the important part here is we're actually deploying to a CPU instance, even though we trained with a GPU. So we may want to always do that because CPUs may be just as performant for inference, but they'll be less expensive to keep up and running as a live endpoint. So we'll create that, and when that's finished, we can start generating predictions for our models in real time. So I'll run this cell just to show that it is possible to, in real time, get back a prediction of what comes out of our model. So we've sent in a payload that has a number of different potential video titles. Some of them are real, so Sherlock Season 1 and 2 are real. Some of them are made up. Sherlock Season 5 didn't exist in our data set. And so we're trying to check and see if that has an embedding close to Sherlock Season 1 and 2, which we would expect. We'd want to recommend that for people who watched Sherlock Season 1 and 2. And then we can look at our what that output comes out, and you can see indeed we've got all of our video titles that we passed in and our 100-dimensional embedding space. So that's what was generated in real time as a prediction from our REST API. And then we'll look at how those items correlate with one another. So we have each of our videos here, and we can see that Sherlock Season 1 and 2 have a very high correlation with one another and a very small Euclidean distance. So that means that, as we might expect, they're going to be very close in that feature space, and we would likely recommend in a cold start situation Sherlock Season 2 to anyone who reviewed Sherlock Season 1. Sherlock Season 5 has less of a tight relationship, but still very tight. And so when that's launched, we'd likely be able to recommend that to customers who reviewed Sherlock Season 1 and 2. We created an arbitrary Sherlock Holmes title just to see how that would relate. Not as well as Sherlock Season 5, but still very strongly. The Imitation Game is another popular Prime Video offering that features Benedict Cumberbatch, who also is in Sherlock Season 1. So it might make sense that we would see some relationship there, and we do see some relationship, although not as close as any of the other actual Sherlock titles. We've also generated just a random arbitrary string of characters to see how that relates. You can see it relates pretty poorly. And then we have Keeping Up with Kardashians, which we would expect to maybe not appeal to the same audience and be very different. And indeed, we see that the relationship between them is almost nothing, and that Keeping Up with Kardashians is very far away from Sherlock Season 1 in that embedding space that we've generated. So, again, just more validation that our model is working, and proof that we can generate these predictions in real time as new items came into either our catalog or as new features were made available. So, wrapping up, we've used this unique technique to find similar products based on review histories and similarity in names. That's very important, is that not only was the Sherlock Season 5 close to Sherlock Season 1 because of the naming. But the random string and Keeping Up with the Kardashians were actually different. But Keeping Up with the Kardashians is even more different, not just because the name doesn't have any sort of relationship, but because the review history played in as well. So it's important that both of those things happen in a cold start approach. We also trained on a GPU instance while orchestrating from a small CPU instance, which is an important functionality and capability of SageMaker. We created a live CPU endpoint to generate predictions in real time. And we noticed that our model captured the similarities between videos that we kind of subjectively evaluated to make sense and be good. So we could potentially use those in a system of our own. To end, we'll clean up the endpoint and make sure that we shut that down so that we don't incur any costs of that endpoint running. And that's it. So thank you for joining us today at this SageMaker webinar, and we'll take time for question and answer now.